Okay, so we're doing 135 degrees for that one. So then we want to find the measure of the angle that's complementary to 45 degrees. So DeMarcus, complementary, how much is that? 90 degrees. So how do we find the one that's complementary to this one? And it'll be, yep, 45 degrees. Okay, so angle or 1 and angle with the measure of 122. Taylor, what is the relationship between these two angles? They're linear pairs. So how do I find this measure here? 180 minus 122. And what do you get? 58 degrees. Okay, so that's because they were linear pairs. Now, Dante, you ready? So here, what's the relationship between this angle and this angle? They're vertical. What do we know about vertical angles? You've got this. So what is this measure going to have to be? It's going to have to be 122 because we know that vertical angles are congruent. So 122 degrees, and we have vert angles. Okay, and then over here we have 3. And we're going to go back there, Trinity. What does the 3 have to be? So what's the relationship between these two angles? So if this one is, then this one has to be? Yep, so we have this one as 58 as well. Okay, do you guys have any questions on this part? So we use linear pairs, 180 minus 122. You got your value, and then after that, it's just vertical angles. The angles that are directly across from each other, those kissy fish. Okay, so then we are on to our objective. So at the top of your page, you're adding on to your objective is to be able to identify relationships between lines. And today's lesson is 3.1, relationships between lines. Okay. So we have some vocab today. I'm going to give you a second to write them, and then I will read them to you. So our first line here was parallel lines. 2 lines that lie in the same plane and do not intersect. So our important part there is that they lie in the same plane and that they do not intersect. The symbol for is parallel to is those 2 lines. They look like L's or absolute value lines, so just a little taller than L's. You can see that in action on our little example here. You see M, and then you have the 2 parallel lines to N. But there's also something on the lines themselves that tell us that they're parallel. Can anybody see what that symbol is that tells us that they're parallel on the lines? So what did you say it was? The like that thing or these? So this definitely does tell us, but there's actually something that's on these 2 lines that also tell us. Can anybody see or do you want to take a guess on what actually tells us on our lines here? What did you say? So it's kind of hard to see back there, but these lines both have arrows on them. So we can denote parallel lines by putting arrows on the lines that are parallel. So on this one, I'm going to just highlight it in red so you can kind of see what's happening. We have a little arrow here, and we have an arrow here. And this tells us that we know that these 2 lines are parallel. So anytime you see that, you know that the lines are parallel. We also have perpendicular lines. These are 2 lines that intersect at a right angle. The symbol for perpendicular to is, I don't have that on my keyboard, so I apologize. I have to draw it in. It is that upside down T. So an upside down T is that perpendicular. And then we know if it's perpendicular, it means it forms a right angle. Right angles have how much degrees? 90. So you see that in this picture that the red box indicates that it is a right angle. So you see that M and N are perpendicular to each other. And you see that written in symbol form down here. M is perpendicular to N. Do you guys have any questions on this portion? Are you guys still writing this down? Okay, I'll give you a second. Our first one here is skew lines. These are 2 lines that do not lie in the same plane and do not intersect. So the part of this that is different than your parallel is the fact that they do not lie in the same plane, but they, just like parallel, they do not intersect. So to give you an example of skew, I want to talk to you first about things that lie in the same plane. So if we had this front crease of our board is equivalent to this portion of my box, right? So right here, this crease of my box is this front crease of my board. So the back crease right there and this line form a plane, right? If you look over here, this crease of my wall up here would be this one here and this one here. Again, if you look at them, those two lines form a whole side of the box. They're again forming a plane, right? So they lie in the same plane. And then again on the back corner here and this front corner, it's harder to see on a box, but I have these little door stoppers. Same idea as the box. So if this was this corner up front and this is the corner in the back, if you slice it, you get again another plane. So anything that is parallel to that line will never be skew. So all of the little corners, lines that form our room are all parallel to our original line and therefore form a plane. With that, then we need something that's not going to intersect. So I'm going to pick up my other box again. So again, if we're looking for something that is skew to this corner here, you want something that's not going to intersect. So I'm going to turn it. So this is this corner still. This line here is equivalent to this top line in my room, or this bottom crease. It intersects with this, right? It runs into this wall right here. So this would not be skew. So this line here, not skew. Same thing occurs with our top crease right here. It hits that same line. It's not skew. And over here you have the same thing. That top crease runs right into this line. Not skew. They intersect. And then this one runs into it. Not skew. They intersect. So the ones that you have as options are that bottom crease against the wall. If our plane is the floor, right, and I am the line, I am forming a right angle with the floor, right? So our floor is the plane and I am the line. As I walk around every spot, I am perpendicular to the plane. I'm not in the plane, I'm not lying on the floor, but I am forming that right angle with everywhere I step. So I am perpendicular to the plane that is our floor. Okay, so again, parallel planes, the two walls, and then we have that skew, same plane, or do not lie in the same plane, and do not intersect. Okay, so after that, we're ready to jump into our examples. Here, we want to determine whether the lines are parallel, perpendicular, or neither. So, Jaquan, we were at U. I'm going to read which one we're on. So, we have line V and line X. Are those parallel, perpendicular, or neither? So, V and X. They're perpendicular, and how'd you know that? Yep, they intersect, and he saw they had that little box for a right angle. So they intersect. So you can either write the word perpendicular, or I will accept the symbol as long as you write the symbol correctly. Or you can write perpendicular. Okay, after that, we have V and Y. We're moving over to Natalie. So V and Y, are they parallel, perpendicular, or neither? They're going to be neither. So you see that they're not parallel because they intersect, but there's no sign here to tell you how they intersect. So when they intersect, you don't see that they are right angles. So therefore, we know it's going to be neither. Okay, E, you ready? We have W and Y. Are they parallel, perpendicular, or neither? And how'd you know they're parallel? So they're not going to touch, and you also see, once again, that those arrows that are on there denote that they're parallel. So we see they're parallel because we have our symbols as well. So again, the arrows tell us that. If you had multiple sets of parallel lines, but they weren't all parallel to themselves or to each other, you would denote them by additional arrows, just like we do with congruence. Okay, so example 2, we want to determine whether the line is skew. So we have K and M. So K and M. So Raj, do K and M lie in the same plane? So in the plane here is this parallelogram that's representing our plane. So do they both lie in the same plane? So this one's just slicing through it, and this one's on. So no, they don't lie in the same plane. So they don't lie in the same plane. So what was our definition of skew? Sierra, do you want to tell me that one again real quick?
Two lines that do not lie in the same plane and do not intersect.
So do not lie in the same plane, do not intersect. So right now we see they don't lie in the same plane. So do these two lines intersect, Deshaun? So does this line here intersect with this line here?
Wait, which one?
So this one here, M and K. Sean, do either of those intersect? So we're talking about this one here and this one here. Do these two lines intersect? This one and this one? We're talking about this one here and this one here. Do they cross? Nope. So we see they don't cross. They don't lie in the same plane, so they are skew. Well, it's going to change slides because I wrote down, so I have to go back and then put on my annotate. So we say that they are indeed skew because they don't lie in the same plane and they don't intersect. So now we have line L and line M. So L and M, we're going over here to 1. So do these lines lie in the same plane, L and M? No, they do not. Do they intersect? So are they skew? No, they are not. So since they intersect, we say not skew because they intersect.
We're going to say that?
Yep, you are justifying what you know. Our first one is name a plane that appears to be parallel with G. So which plane is parallel to G? You're close. So remember where they look like when we name planes? They're going to be those bold letters on the top corner, or they're going to be named by how many points? Anybody? Kevin? Oh, hold on. How many points does a plane need? You need 3 points, right? So which one is going to be parallel if we're naming it by the letters on top? You're close. So here, real quick. So remember, we're going to look for ones that don't intersect. So we're here. So you have this one and this one, right? So if this one's G, which one's not going to be? Who's our other one going to be? Yep, so it's going to be F. Yep. So we know that it's going to be parallel to plane F. So remember, real quick, that those are those letters in the corner. I just want you guys to see those. And the other point would be 3 letters, or 3 points on that same plane. So we say plane by the points. But here we don't have any points on the plane. We only have line names. So you wouldn't be able to name it by anything else. With that, so we see it's plane F. So that would be this far wall over here and this wall over here. They're never going to cross. And then we have name a line that is perpendicular to F. So name a line that's perpendicular to F. So Delaney or Nunu, what is a line that's perpendicular to our plane F? So what does it mean to be perpendicular? Intersect and form? Yep, so what intersects this line and forms a right angle? So do you want to just describe it to me? This one? Yep, and so it's a little hard to see. I call this a cursive L. It kind of looks like an E. I'll accept either of them on your page. So I wrote line L. So you see that line cuts straight through like she said, and it forms that right angle right here with that plane. Do you guys have any questions at this point? Any questions at all? Okay. So our last example, before we go through it, I want you to take a second and try it and then talk to your buddy and compare answers. So you are naming a line that is skew to VW. You are naming a plane that appears to be parallel to plane VWX. And you're naming a line that appears to be perpendicular to plane VWX. So you're going to take a second and you're going to work on that and then you're going to talk to your buddy. Come up with a solution to those 3 questions. So we're looking for something skewed to that line, a plane that's parallel to a plane, and then that's perpendicular to a line. Except Jasmine, you're trying to. I'm just running short on them. This is a big area you need to cover.
No, it's just these because I did stems.
Okay, I'll see if I have to, okay? I should at least have one. So after you have decided, discuss with the buddies, see if that reasoning holds true. So our first one was name a segment that is skew to line VW. Did anybody come up with a line that's skew? Raj? So ST would be correct. That one does work. So if you wanted to put ST, remember you name it, is it a line or a segment? On yours it says line or segment. I think it says segment. So does it say line? Okay, so then that would be ST, and you put the arrows on top of it. So that would be this right here. So again, front crease of our classroom, right over there, right? And then that would be our floor over here. Those are never going to intersect. They don't lie in the same plane. We have 3 other lines that are skew. Can somebody else tell me a different one?
Oh, I did have it.
Yep.
RS.
So RS is actually not going to be skew because RS would be equivalent to this line right up here. And so those 2 lines would form a plane. So it'd be form that flat section of your box. So it'd just be this side here with this one, and you'd end up with this side of the box. Yes, sir?
I did QT for
QT also will unfortunately not work. So again, guys, when we have that, if this line here is the one that you're trying to be skewed to, anything that is running parallel to that is going to form a plane. So this crease up here, so this one and this one would be equivalent to this crease and that's forming our wall or the side of our box. The same thing with that back crease right here. So that would be the UT. Wouldn't work because it's forming this side of the box. And that one in that corner wouldn't work because that's that slice in the middle and it's creating this plane right here. So it's that sliced plane in the middle. So I have a bunch of other people's hands up. Let's try Jaquan. Which one did you get? RQ works. So RQ would be the equivalent to the top part of this wall up here and this corner by my door. So RQ. Or QR, either one works. Raj, you had your hand up. Did you have another one that you want to talk about?
I was going to say it, but WX.
So you're close. WX is, when it's, this would be the equivalent to this one right here and the one on the floor. And so they would be in the same plane and they would intersect. So that one would have to be ruled out. So, do you have another one you want to try? TX works. So TX does not intersect that line. And it does not lie in the same plane. So that's this part right here, TX. Okay, and then you want to do our last one? QU as well. Keena, I'm sorry, was that the one you were going to say too?
Yeah.
Thank you guys. QU. Okay. You only needed one, but I think all of them allow you to see it. So again, if you see that this is your line, everything that runs parallel gets cut out immediately. And then the ones that hit it also get cut out. They're no longer options. So that would be these 2 sides and these 2 sides that we didn't highlight. So we know that those will not work because they intersect. After that, we want to name a plane that appears to be parallel to VWX. So that plane is VWX. That's the equivalent to this wall right here. Yeah, Dante? Yep, plane RQT works for me. Plane RQT. So you see that would be equivalent to the wall over here. You can name it with any 3 points. So you could have named it RQT like he did. You could have named it RST. You could have named it TSR, TSQ. Any combination of those with 3 of those 4 letters, you can name the plane. Okay, and then we want to name a segment that is perpendicular to the plane. What does it mean to be perpendicular? Intersects, forms a right angle. So we're talking about that plane again, that VWX. Which segments or lines form perpendicular lines? Yep, Taylor? QU works. So you have QU. We have a couple others. So I want us to name them just in the case. So what's another one that's perpendicular? So you saw here that QU came in. It formed a right angle. Yep, Raj? Okay, does anybody else want to try? Jasmine's group back there. I haven't called on any of you three yet today. So a segment that's going to intersect and form a right angle with that plane. Yeah, Raj?
I feel T is B.
Which one did you say, Hein? So TS?
No, T is R.
So you're naming a parallel plane. So you only need 2 letters because we're just naming a segment. So just the segments that are going to run into it and form a right angle. So we only need just the 2 letters to across. Jaquan? RS. So RS is over here. So that would be this line of our classroom. And we're hoping to make a right angle with this wall over here. So are those going to intersect and form a right angle? So that's what we're looking for in terms of this classroom. If this is the wall, that's our plane. Which ones are forming that right angle? So if you looked at this, we see that we have right angles forming where? Taylor? SW could be one, yep. So here, you have SW, and that's forming a right angle right here. So again, if this is the wall, I would actually like to use this box again so I can move it. And this is our plane that we're trying to find things that are perpendicular to, segments that are perpendicular to this wall right here. Well, the things that are intersecting it are this line right here, this line right here, this line right here, and this line right here. Do all of those form right angles? So if you look on your box, is this a right angle? It is, right? So we know the things that are directly forming that box are going to be the lines that are intersecting it perpendicularly. So we have 2 of them. So what are our final 2? Our final 2. Yes, ma'am? You've got this. Maybe if you don't, we'll explain it again and we can keep going. So US themselves actually aren't aligned. It's a that would be the diagonal. Oh, X. So that's one side of that plane. So which ones intersect that plane still? So if you had this line, there's still a line that intersects that to form a right angle. T what? Yep, TX. So you see that TX intersects it here, and it forms that right angle right here. And we have one more lonely one up here. It intersects that plane, the side of my box, and it forms that right angle. So which one's that going to be? RV. Okay. So that is our part here. So today we've talked about parallel lines. So parallel lines are what? Lines that don't intersect. We talked about perpendicular lines. 2 lines intersect, form a right angle. We talked about skew lines. What are skew lines? Yep, two lines that don't line the same plane or don't intersect. Okay, so I have 2 other things that we're doing. I have a thumbs rating first, so there's 3. I want you to rate how you're feeling right now with the thumbs. Pretty good. I'm struggling a little bit. I need a little more help. Or I need a lot more help. So which part are we at? So I'm going to need to see your rating. Nunu Hunt. Yusuf. Jasmine. Okay, Dante Hunt. Thumbs rating. Okay. So with that, after this, I have 2 activities. Your first one is going to be an exit ticket. I'm going to give you that paper in a second. I'm going to have you answer it. When you're done with it, you're going to put it in the air. I'll collect it, and then we'll give you a partner activity. Your partner activity means you're talking to your partner. So I'm going to go over this real quick. You're going to be getting a picture that looks just like this. And on that partner activity, you're going to have to identify 10 parallel lines and 5 perpendicular lines. So when you do it, I want you to identify your parallel lines. So if I'm using it, you're not going to use this one. You're going to circle them, and you're going to label it 1. So I have 1 set there. So you cannot use that. But along with that, you can't keep picking similar ideas. So if I picked that one already, I can't go down here and identify this one as 2 because we already covered that group. There are plenty of parallel lines in here for you to find more than 10. So we have that. And then you have 5 perpendicular lines. So over here, perpendicular lines. I see I have a perpendicular line right here. I highlight it, and then I write 1 next to it. Do you guys have any questions on the partner activity? So you're doing that with a buddy. I'd prefer if you have like a pen of a different color or at least a pen that's dark to be able to use that so I can see it on your page. It might show up a little better than a pencil. And then I'm giving you both one of these so you guys can look at them, but you only have to turn in one with both your names on it, okay?